Hello everyone and welcome to the MathDBase.com Anacast series. I'm your host, John Kasiedu. In this installment in the Developmental Mathematics series, I will discuss Addition Tactics Part 2, Gaussian Counting. Carl Friedrich Gauss was a German mathematician and mathematical physicist who lived during the 18th and 19th centuries, and is considered, along with Isaac Newton and Archimedes of Syracuse, to be one of the three greatest mathematicians of all time. The story has been told that Gauss discovered this method of quickly determining sums during an assignment in elementary school, much to the astonishment of his teacher, who wasn't aware of the technique. To see how Gaussian counting works, let's start with a set of natural numbers from 1 to 10. There are 10 numbers to add, which can be separated into two groups of 5, half of 10, which is exactly the same as adding the two groups with the second group of 10 in reverse order, which can be rearranged again and grouped as pairs, creating 5 pairs, each with a sum of 11. The total sum is 5 times 11, or 55. The order in which addends are arranged, the commutative property of addition, or how they are grouped, the associative property of addition, do not affect their sum. Since 10, the number of addends, is even, all of the addends can be paired with none left over. The number of pairs is half of the number of addends, 5 in this last example. The key to finding sums in this way is how the numbers are paired, the first with the last, the second with the next to last, etc., until all of the addends are coupled. When combined in this way, the pairs will always have the same sum. To find the sum of the first 100 natural numbers, we have 100 numbers which can be written as two groups of 50. The first from 1 to 50 and the second from 51 to 100. The order of the addends in the second group can be reversed, which can be rearranged and recombined, creating 50 pairs, each with a sum of 101. The total sum is 50 times 101, or 5050. If the number of addends is odd, work similarly with the largest even number of addends, then add the last addend to that result. To find the sum of the first 11 natural numbers, take the result from the sum from 1 to 10, then add 11, or 55 plus 11, which equals 66. To find the sum of the natural numbers from 531 to 539, write out the numbers in summation form. There are 9 numbers to add. Group the largest even number of consecutive addends, rearrange and pair the numbers. Finding the partial sums, there are 4 pairs, each with a sum of 1069 and one addend, the 539 left over. The total sum is 4 times 1069 plus 539, which is equal to 4276 plus 539, or 4815. What if we want to find the sum of a consecutive sequence of natural numbers that are too numerous to write out? Let's look at the example of finding the sum of the first 10,001 natural numbers. It is not necessary to write out 10,001 numbers, but instead, group the numbers as the sum from 1 through 10,000, the largest even number of addends, and 10,001. Then rewrite the numbers as two groups of sums, finding the cutoff point by dividing 10,000 by 2, to create two groups of 5,000 addends, plus 10,001 at the end, which is equivalent to the sum of the addends with the second group in reverse order. Rearrange and regroup the addends. There are 5,000 pairs, each with a partial sum of 10,001. The total is 5,000 times 10,001 plus 10,001, which is equal to 50,015,001. Sometimes it is simpler to just change the problem. For example, to find the sum of the natural numbers from 7 through 243, you can make use of the fact that the sum from 7 through 243 is equal to the sum from 1 through 243 minus the sum from 1 to 6. Starting as we did before, group the numbers as the sum from 1 through 242, the largest even number of addends, and 243. Then rewrite the numbers as two groups of sums, finding the cutoff point by dividing 242 by 2 to create two groups of 121 addends, plus 243 at the end. Reversing the order of the second group and pairing as in previous examples, we have 121 pairs, each with a sum of 243. The sum is 121 times 243 plus 243, or 29,646. The sum from 1 to 6 is 21, so the sum from 7 through 243 is 29,646 minus 21, or 29,625.